Okay, so on 15, it shows a picture. It looks like this. Okay, we're graphing this as y equals 5. That's your force or your velocity. You can think of it as velocity if that makes you happier. It's probably what I'd call is velocity versus time. What does that tell you? It tells you you're going 5 meters per second, 5 miles an hour, whatever it is. It's constant. So in other words, your displacement is changing at a rate of 5 meters per second. Okay, that's what that's telling me. Now, if I integrate this from 0 out to, so in other words, you're going to be integrating from this 0 out to some x of 5. That is my f of t dt. Well, you will see this goes 5t from 0 to x, and so that's just 5x. Okay? In other words, what is the area of this thing? I don't know. But if I come out here to x, like what? X equals what? Well, like x equals 2. If I plug this in, if I were to go from, in other words, if I were to put 2 up here instead, right? The difference would be I'd have 5 times 2 minus 0, of course. That's stupid. All I need to do is then just take and plug this fella in. Just go 5 times 2. That's it. Bam, that's your area function, right? Which is equal to 10. What does that mean? It means I went 10 meters in 2 seconds when I have this velocity, which happens to be a constant velocity of 5 meters per second. Well, duh. Okay, does that make sense? Obviously, that's true. Now, what is the change in my area function with respect to time? Or with respect to x, rather. Sorry. With respect to x, ddx of this thing. Well, wait, what is the derivative of 5x? Well, it's just 5. What does that mean exactly? Well, that means that is how fast we're changing the area, right? In our case, we're changing it at 5 meters per second. In other words, here's 1 second, we gain 5 meters. Here's a second, we gain 5 more meters, right? And in this case, because it's constant, that's all it is. Okay? But it's possible that you had one that was like, I don't know, 5t plus 7 or something. That was your velocity function. By the way, that means your velocity looks like this. You are not gaining it at a constant rate anymore. It's increasing. Well, and let's say you started at 0 and went up to x. Okay, well, this would be 5t squared over 2 plus 7t from 0 to x, which means you're going to get 5x squared over 2 plus 7x. Okay, and then let's say I said to you, hey, in 2 seconds, where are you? Or, how far have you gone? I don't know. 20 divided by 2 is 10, plus 14 is 24. So in the first 2 seconds, we will have traveled 24 meters. Okay, that's cute. So again, this is your area function. Well, what's the derivative of your area function? It's going to be 10x over 2 plus 7, or in other words, 5x plus 7. It undoes it. Okay, so you tell me when we are. So we are at t equals 1. All right, cool. I can tell you how fast we're changing because I can tell you the velocity at that point. Okay, and again, to me, velocity displacement is just the way I think of this problem. You can do it other ways, but to me, that's just the way to do it. Like sands through the hourglass, so are the days of our lives. Anyway, if that's what's up to you is how many grains per second it is, and then how much grain has fallen through. That works too. It's just weird.